Okay, we have section 7.3, which is finding volume again, using this time the shell method. So the shell method is to find the volume of the cylinder that's being revolved minus the volume of the hole. So it's a little different than the washer method where we subtracted it right away. We find the volume of the shell. So this is a little bit different. If we have a horizontal axis of revolution, and we have this shape over here to revolve around the horizontal axis. It's going to be from C to D is going to be our limits of integration, and we're always going to want to draw in that rectangle. The volume is 2 pi times the integral from C to D of P to Y. Now P of Y is the distance it takes to get to the rectangle, and the H of Y is the height of the rectangle, which is generally going to be your function. Now if we're flipping around the vertical axis, a similar looking shape, we're integrating from A to B, and again you want to draw in your rectangle. When you're using the shell method, it's always going to be parallel to the axis of revolution. So P of X is going to be the distance it takes to get to the rectangle, and your H of X is the height of the rectangle. Okay, so find the volume of the solid of revolution formed by revolving the region bounded by x minus x cubed and the x-axis from 0 to 1 about the y-axis. So we're going to be flipping it around the y-axis. The function looks something like that. This is from 0 to 1. We're trying to flip it around the y-axis. So what you want to do is identify what your p of x and your h of x are. We have to draw in a rectangle. It's going to be parallel to our axis. So p of x is going to be the distance that it takes to get to your rectangle. In this case, you could draw a rectangle anywhere, and the distance away would be x. And the height, h of x, at any point is your function, x minus x cubed. That's generally the way it's going to go. The distance to get to your rectangle is generally going to be your variable, x or y, unless you're revolving it around something other than an axis. So your volume is, in this case, because it's a shell, 2 pi from 0 to 1 of p of x times h of x, which is x times x minus x cubed dx, which is x squared minus x to the 4th. Take the integral of that, x to the 3rd over 3 minus x to the 5th over 5 from 0 to 1, which is 4 pi over 15. Okay. And now we're going to find the volume of a solid formed by revolving the region of x equals e to the negative y squared and the y-axis about the x-axis. We're flipping it over the x-axis this time. And our limits are from 0 to 1 on the y-axis. So our function looks something like that. We're flipping it over the x-axis. And it's good that our function is in terms of y's because we have to draw our rectangle this way. So everything needs to be in terms of y's. So our p of y is the height that it takes to get to our rectangle. Since we could draw a rectangle anywhere, that is y. And then our h of y is the height of the rectangle, which is the function e to the negative y squared. This is from 0 to 1. 2 pi from 0 to 1 of p of y times h of y, which is y times e to the negative y squared dy. This is going to be u substitution. U equals negative y squared. du equals negative 2y dy. You have to divide by negative 2 equals y dy. And without changing our integrating limits, if we divide by negative 2, it's just going to be negative pi on the outside, e to the u du, which is just e to the u. So negative pi times e to the negative y squared, evaluated from 0 to 1, which is about 1.986. Okay, so down here, this is going to be a really helpful chart for you to study to help you figure out the difference between the disk and the shell methods. There's going to be 4 different diagrams. And they're all going to be about the same shape, so let's start there. Let's draw something with about the same shape. Okay. So if I am revolving around the y-axis and I'm doing the disk method, we're going to have the disk method on these first two. From C to D, we would have a rectangular perpendicular. We would have a capital R and a little r. So our volume would be pi times the integral from C to D of capital R squared minus little r squared dy. And if I was revolving around the x-axis, I would have from A to B a capital R squared and a little r. So our volume in this case is pi times the integral from A to B of r squared minus r squared dx. So something to mention about the disk method, I think I mentioned this a couple times already, but the rectangle that you draw is always going to be perpendicular to your axis of revolution. Okay, now these two are going to be the shell. If I'm revolving around the y-axis, we are going to go from A to B, and you're going to draw in your rectangle. It's going to be parallel to our axis of revolution. We're going to have a P of x in this case. That's the distance it takes to get to your rectangle, and the height, h of y, and the volume is going to be 2 pi times the integral from A to B of p of x. Oops, this should be an x up here. P of x, h of x, dx. And then if we're flipping around the x-axis, we're going to go from C to D, draw on our rectangle. So the first one is P of y, the distance it takes to get to the rectangle, and h of y, which is the height of the rectangle, and our volume is 2 pi times the integral from C to D of P of y, h of y. And the reminder is that the rectangle is parallel to the axis of revolution. Okay, so that's a good thing to note. Okay, now we are going to find when the shell method will be preferable. We want to find the volume of the solid formed by revolving the region bounded by the graphs x squared plus 1, x equals 0, y equals 0, x equals 1 about the y-axis. So we're flipping it around the y-axis. We actually did this question in the last section, the one where we split it up into two. So I'm going to very quickly review what we did on that one. We did the washer method. And we split it up into two different ones. We went from 0 to 1, and that was just the disk. And then we did the top half, which was the actual washer. We changed it into the y terms. Okay, I'm going quickly because this we did in the last section. Take the integral of it. We have y from 0 to 1, and we have 2y minus y squared over 2 from 1 to 2. We got 3 pi over 2. Now I want to show you what it would be like to do the shell method with this problem. So remember, if we did the washer, we would have to make our rectangles horizontal. If we're doing the shell, still flipping it around the y-axis, we make our rectangle parallel, and we have to figure out what the h of x and p of x are. The p of x is just x because it's the distance to your rectangle, and the h of x is x squared plus 1. The volume of the shell method would be 2 pi from 0 to 1, because we do from a to b, p of x times h of x. Skipping a step here. Distribute, take the integral, and it's 2 pi times 3/4, which is 3 pi over 2. So obviously it was a lot faster to do the shell method on that one than it was to split it into two and use the disk and washer. So just think about that. Whenever you are flipping over the y-axis, you should check and see if the shell method would be easier. Okay, now we're making a pontoon. The shape shown will make the shape up here. Okay, it's 2 feet tall and 8 feet long. So the shape we're going to use 1 minus x squared over 16. We're going to use that graph. On top we're going to use the disk method. So our rectangle is going to be this way if we're flipping over the x-axis. And it's going to be really easy disk method here. Pi from -4 to 4 of the function 1 minus x squared over 16, quantity squared, dx. All right, take the integral. Oops. X minus x cubed over 24 plus x to the 5th over 1280, evaluated from -4 to 4. It's 64 pi over 15 feet cubed for the volume. Now let's look at what would happen if we did the shell method. We would need to find a rectangle. It would have to be parallel to your axis of revolution. And you need to change the function into terms of y's. And we can already tell already that we don't want to do the shell method. Shell method is difficult on this one, so we would obviously use the disk, which was just fine. And the last one, we're trying to find the volume of a solid form by revolving the region bounded by the graph of x cubed plus x plus 1, x and y equals 1, and x equals 1. So this is 1 right here, about the line x equals 2. So we're going to do the shell method on this one. We're flipping it over x equals 2. So our p of x, we have to draw on a rectangle. Our p of x, the distance from the axis to the rectangle is actually 2 minus x. So it's a little bit different when we're revolving it around something that's not an axis, horizontal or vertical axis, y or x. And then the h of x is the height, which is x cubed plus x plus 1 minus 1, because we have that, I have to do f minus g to find the area in between those two. So it's a little bit different. 2 pi times the integral from 0 to 1 of p of x, which is 2 minus x, times x cubed plus x. Remember that the 1's would cancel there. Dx. Distributing this, it would be negative x to the 4th plus 2x third minus x squared plus 2x dx. 2 pi times negative 1/5 plus 1/2 minus 1/3 plus 1. It's 29 pi over 15. So if it's being revolved around x equals 2 in a case like that, we know that we want to use the shell method. Just a quick little fix. We want to do 16 through 20 even instead of 14 through 22. And we are done with section 3.